Dear students, in this video we'll be learning about the postulates given by the father of geometry, Euclid. Look at the picture. He is the father of geometry, Euclid. Euclid's postulates. You have learnt about axioms in our last video. Axioms are statements which are self-evident or assumed to be true within context of a particular mathematical system. That is, in everywhere in mathematics, in all the branches of mathematics, axioms are used by Euclid. But coming to postulates, they are similar to axioms in the sense that they are also the statements which are self-evident or assumed to be true, but the postulates term is used by Euclid for the assumptions made in geometry. That is, postulates are limited to geometry. Euclid used the term postulates for the assumptions made in geometry. That's how axioms and postulates differ, children. Axioms anywhere in mathematics, postulates in geometry. That is the difference. Children, let us mark 2 points A and B. You can observe there are 2 points here marked as A and B. Now, if I want to join or draw a line through these 2 points, how many such lines can be drawn? How many lines can I draw? Yes, 1. Joining these 2 points. That's what the postulate of Euclid, the first postulate of Euclid says. There is a unique line that passes through the given 2 distinct points. Here the 2 distinct points are A and B. When I wanted to draw a line passing through these 2 points, I could draw one line. Just tell me, children, can we draw one more line passing through these points? If at all you draw, it will coincide with the line which we have already drawn. He called this line segment as terminated line. Because it is ending at A and B, Euclid called this as a terminated line, which we are calling as line segment now. So, as per his first postulate, there is a unique line, that is one and only one line that passes through the given 2 distinct points. That is his first postulate. Let us see what the second postulate of Euclid tells us. Yes. Postulate 2 of Euclid says, a line segment can be extended on either side to form a straight line. Just now we have seen a line segment from A to B. Now if I extend towards the right side of B and left to A, on either sides I am extending. So if I do that, I will be getting a straight line. That's what the second postulate of Euclid informs us. A line segment can be extended on either side, that is both the sides, to form a straight line. Okay, that is very clear. That's why these are considered as the statements that are self-evident, very clear, and hence named as postulates. Let us see postulate 3 given by Euclid. We can draw or we can describe a circle with any center and radius. That is, if any center and any radius is given to us, that is a center and a radius is given to us, we can draw a circle. That is the meaning of this statement. This postulate 3 says that we can describe a circle with any center and radius. So let us take 2 points. I am taking a point U here and I'll consider this as a center. And I am marking one more point, and this distance, the distance from U to V, will be considered as radius. Let us see what we can do with the given information. U is the center and the distance UV is the radius. Let us see, can we draw a circle? Yes, you know very well, children. That's the reason we are saying that these statements are self-evident. They are self-evident truths. They are very clear statements. They are assumed to be true. It is very evident that when a center and radius are given, we can draw a circle. That is, the postulate 3 says that given a center and the radius, you can describe a circle. This is postulate number 3. Let us see the fourth postulate given by Euclid. Let us consider few angles. You can see that the symbol says that this is a right angle. Now here we have considered one more right angle. You can observe. Here we have one and one more we have here. Let us draw one more. Yes, this is also a right angle. You know very well. We'll keep a square symbol as angle when the angle is 90 degrees. So let us see. I'm just bringing this angle closer to our first angle, and when it is placed on it, it is equal to the first one. Of course, it will be equal because both are 90 degrees. Now let us see the other third angle also. I have just flipped it, and when it is placed, it's also coincided with the first 90 degrees angle. It's very clear. All the 90 degrees angles are equal. That's how the postulate 4 says all right angles are equal to one another. So we have considered 3 right angles here, and we have even seen that they are equal to one another. So it is a self-evident truth given by Euclid, and as it is related to geometry, we call it as postulate. This is postulate number 4. All right angles are equal to one another. Now let us see the fifth postulate given in our textbook. Let us consider a line L, one more line M. Now if a line passes through these two lines, that is if it intersects these two lines which we have drawn earlier, then let us consider the angle made at this point, angle 1, and let us consider the interior angle on the same side of this transversal, angle 2 here. So we are just looking at the two angles, we are just considering these two angles, and let us measure the angle 1 and angle 2, and let us see what is the sum of these two angles. So the sum of these two angles happens to be less than 180 degrees. So what postulate 5 says is, if we extend it, these two lines, then these two lines meet at a point, that is intersect at a point. So that's what the postulate 5 says. If a straight line falling on two straight lines makes the interior angles on the same side of it taken together is less than 2 right angles. That's what we did, children. We have considered a line first and one more line, and this is the line which falls on these two lines as per the statement, falling on the two straight lines. Line N falls on these two straight lines L and M. And we have taken the angle 1 and angle 2, and whose sum is less than 180 degrees, which we have seen. So as per the statement, if the sum of the interior angles on the same side of it taken together is less than two right angles means two 90s, that is 180. If that is less than, the sum of angle 1 and angle 2 is less than 180 degrees, then the two straight lines, that is line L and line M, if produced infinitely, that means if you just produce them in this side where the interior angle sum is less than 180 degrees, if you extend these two lines in this direction, what happens? They meet on that side on which the sum of the angles is less than two right angles. So if you extend them this side where the interior angle sum is less than 180 degrees, these two lines intersect at a point. That is the postulate phi given by Euclid. So that's how, children, we'll just try to understand it once again. If a straight line falling on two straight lines, that is line L is falling on line L, line N is falling on line L and line M, makes the interior angles on the same side of it taken together is less than two right angles. These interior angles, angle 1 and angle 2, when added, taken together means when added, is less than two right angles, that is less than 180 degrees. Then the two straight lines, if produced infinitely, meet on that side on which the sum of the angles is less than two right angles. So if we just produce them infinitely, then these two lines meet in the direction where the sum of these two interior angles is less than 180 degrees. They are intersecting lines, they meet at this point. This is the fifth postulate given by Euclid. So that's all for today, children. We learnt about Euclid's 5 postulates in this video. That's all for today. Have a good day.